would be nice if we could factor, because that would cut down on some of the work we have to do. So let's try that. Well, we know that the factoring is the undoing of the distributing or multiplying. We multiply two factors to get a product. So right off the bat, I always like to write down that it is our goal to fill in these two linear factors with things that multiply to give us this. Okay, so let's see. Well, I also know that in order to get an x squared, I'm going to need an x by an x. So this first term, we would need something by something to get 5x squared. Well, the way I see it, that's going to be a 5x and an x. Now, if it had been something like 4x squared, then maybe it would be an x times a 4x, or a 2x by a 2x, because 2 by 2 makes 4. But in this case, it's nice because you're going to need an x by an x, and you're also going to need a 5 by a 1. So here we have 5x and 1x to give us 5x squareds, right? Okay, so far so good. And then we're also going to need, now I'm going to pinpoint this this 2 business. Okay, and from this plus 2 business, we are going to need something by something equals 2. 2 and 1. But now with this floating in my head, so I went positive style here, which is good. There are infinitely many ways to multiply to get to 2, as there were with the 24. My first gut instinct was to use a 1 by 2 or a 2 by 1. But I also know that we could do half of 4 or 4 halves, and we could go negative style as well. So now I'm thinking, oh boy, I'm going to start with my gut, but I might have to try more than just one attempt here. Yeah? So, first, my gut instinct says, all right, try 2 and 1 first. So, these are, here's my attempts. So let's suppose we did 5x plus 2 times x plus 1. So I filled in this with a 2 and a 1. Yeah? Then, if we multiply, we get 5x squareds plus 5x's plus 2x's plus 2. That's 5x squareds, but notice we have 5x's plus 2x's. That makes plus 7x's. So this did not work out. But the plus 2 did. The 5x squared was right and the 2 was right. It's just that those middle terms, well, they're supposed to add to negative 11. What if I did, instead of 2 by 1, I did 1 by 2? Okay, so what if I did 5x by x to get 5x squared and 1 by 2 to get the 2? So here we go. This would be 5x squareds plus 10x's, because 5x 2 times is 10x, and 1x plus 1x plus 2. Hey, this is pretty close. because now instead of 7 x's, I have 11 of them. It just needed to be negative. So I think I'm going to make this a negative and this a negative, because a -1 times a -2 will still be a +2. Okay, so it looks like here's what we have just decided. +2 plus 1, no. +1 plus 2, no. But if we do 5x, this was close, -1 times x minus 2, and we check this, let's see if it works out. We have 5x squared minus 10x's minus 1x's, so minus 11x's, and then -1 by -2 is +2. And then, of course, we go back to our graphing calculator, and we say, did I factor right? Okay, so in y1, I'm going to put 5x squared minus 11x's plus 2. And in y2, I'm going to put the quantity 5x minus 1 times, what did we say? X minus 2. X minus 2. And graph. Super! So they perfectly match up, and that means we did our job correctly. Okay, so the factoring of this, so this would mean 5x squared minus 11x plus 2. So this general form of the quadratic is equal to this factored form of the quadratic. Got it. Yay! Let's do it again. Now instead of an x, we have a p. Maybe it's p for percentage, p for population, p for, I don't know. What else could p stand for? Population, percentage, punctuality, all kinds of things. Anyway, let's do it again. So we have p squared minus 7p minus 18 has to equal some factor times another factor. Okay, I always have to start this way so that I know exactly what it means to factor. It means to write something times another something to get what has been given to me. Like a prime factorization tree? Yeah. Right. Here's my first thought. My very first thought is that in order to get something by something to be p squared, they both have to be p. A p by p makes p squared. P. PP. Okay. Yeah, sometimes the maturity of a 12-year-old. Anyway, let's see. So we have these p's here so that we have p squared. And then, oh, now our job is to think what times what equals -18. And now we're gonna have to try some stuff. Well, here we go. And it might take us more attempts. I'm just gonna write down, just so that I don't get frustrated with myself, that this could take some attempts. And that is actually a normal phenomenon. But we know that is true. So here we go. What by what equals -18? Right. How about 3 and 6? So let's suppose, or, yeah, okay. So let's suppose we go, one of them has to be negative, right? So let's go -3. A negative times a positive is a negative. Let's say we go like that, and then we check it, because -3 times 6 is 18, is -18. Okay, attempts. Okay, so, and the only way to double check is to either do this or put it into the graphing calculator. I see p squared, but doing this actually tells me if I'm close or not. So I'm going to go to the trouble of doing this. P by 6 is 6 p's, and p by negative 3 is minus 3 p's, and then negative 3 by 6 is minus 18. Okay. I see in the middle here we have 3 p's, but we need more negatives than positive. This is positive, right? 6 p's take away 3 p's is positive 3 p's. So this, no, not what we're going for. So we're like, nope. Okay. Well, I also know that 2 times 9 is negative 18. So what if I went, I don't know. This one was on the positive side instead of the negative side, and I had more positive than negative. So what if I go plus 2 minus 9? Because then there's less on the positive and more on the negative. Okay, now we check that. So p plus 2 by p minus 9er. I see p squared minus 9 p's plus 2 p's minus 18. And there you have it. I see negative 7 p's right in the middle. So p squared minus 7 p's and minus 18. So that is actually our winner. Yay! So let's write that down. P squared minus 7p minus 18 is equal to p plus 2 by p minus 9. And then, of course, we go back to here and we say, am I right? Am I right? Clear this. X squared minus 7x's minus 18. And the quantity x plus 2 times the quantity x minus 9. Graph it. Oh boy. Well, the good news is that they perfectly line up for what we could see. I'm going to zoom out really quick. Okay, so far so good. Yes, perfect alignment, and hence equality. Okay, so factored, here it is in its general form as a quadratic, and here it is as its factored form as a quadratic. Nice. W. I don't know what W stands for, but let's work this out. So, excuse me, we know that something by something equals W squared, which absolutely means that we start this whole problem. Oh boy, I skipped my first step and I hate doing that, which is W squared minus 7W plus 12 is equal to something times another something. This factor times that factor. And right now, I'm thinking the first thing that's going to go in here is a W by a W to get W squared. A W by W. And then, two things have to multiply to get 12. So this times this equals positive 12. Okay? I don't know, 1 by 2, 2 by 1. 1 by 2, whoa. 1 by 12, 12 by 1. 2 by 6, 6 by 2, 3 by 4, 4 by 3. And then we could go halvesy styles. Yeah, so write down that it might take me many attempts. By the way, there are some other ways to factor, and if you have been taught one of the many various ways to factor, like actually when I'm teaching this in my pure algebra class, I teach the AC method. I've seen some people use squares. I've seen some people use a cross. I've seen some people use a lattice. I mean, there's a lot of different ways that people teach factoring. So just so you know, if you use a method that's different than mine, just make sure, just bounce it off your teacher and make sure it works. Yeah? Okay. What by what makes 12? Well, 1 by 12 makes 12. So let's check it. Okay. W squared plus 12 W's plus 1 W's plus 12. That's a lot of positivity, and we need negative, and that's 13 of them. So this is way off. Okay, too much positivity. We're going to need some negative, because otherwise we're just adding and we'll never get to -7. So, what if we go -2 by -6? Because -6 times -2 makes positive 12. So let's give that a shot, see what happens. Okay, W squared, -6 W's, or minus them, minus 2 W's, and -2 by -6 makes positive 12. That, oh my gosh, that's really, really close. Closer. And what I mean by that is this is -8 W's, and we need -7 W's. So I think the negative idea was good. I think the 2 and 6 were good, not great. So maybe it's 3 and 4. And then, of course, we check it. So, I would see W squared minus 4 W's minus 3 W's. So that really is -7 W's. And then -3 by -4 makes positive. That is our factoring. Okay, so we just said, okay, also check it by multiplying in the calculator. Whoa. As a matter of fact, before I write this down in marker, whoa, a little much there. Little much. Let's go x squared minus 7x plus 12. And we are suggesting x minus 3 times the quantity x minus 4. Okay, here it comes. So far, so good. Perfecto. Oh, man. There was some condensation from my orange juice on that. Right there. Great. Okay, so let's let that dry out. W squared minus 7W plus 12. We have factored correctly into W minus 3 by W minus 4. Yay! Okay, so just in case you've lost touch, we graph, factor, and guess and check to solve quadratic equations. So we're practicing this because we have already practiced our guess and check techniques and our graphing techniques. Okay, so all right. Ooh. Now with this one, I'm looking at this and I'm thinking, well. This is really saying there are 9x squareds, there are 0 x's, and then we subtract 4. And our job, of course, is to fill in these factors. Okay, I'm on it. So what by what equals 9x squared? And what by what equals -2? No, -4. Okay. Right. My heart wants to immediately jump to trying 3 by 3 is 9, x by x is x squared. And 2 by 2 is 4. So, but it's negative 4, so it must be plus 2 and minus 2. My heart immediately saw this and said, oh, 3 by 3 is 9 and 2 by 2 is 4, so let's try this. And I also need you to know I went positive times a negative because it's a negative 4. Okay, but let's make sure that this adds up to no x's. So 3 by 3 is 9, x by x is x squared. So far so good. 3x's 2 times is 6x's, but the opposite, so negative 6x's. 2 sets of 3x, or 3x 2 times, however you want to view it, is positive 6x's, and 2 sets of 2 is 4, but it's the opposite, so minus 4. And this does it. Because take away 6x's, add 6x's is 0x's. Whoa. This was a happy factoring. We got this on our first attempt. It doesn't always happen that you get it on your first attempt. We should have also tried 1x by 9x and maybe 1 by 4 and 4 by 1 and all that jazz. So there were definitely other possibilities. But I really did think to myself, 3 by 3 and 2 by 2. And so I tried that first. And it worked. Yay! So the factoring is, so 9x squared plus 0x minus 4 is equal to 3x plus 2 by 3x minus 2. Voila. Okay, so now let's tie all of this together, yeah? Solving quadratic equations. That was our whole rub. That's the whole idea. Solve this, then graph it. So solve it, then graph it. Okay, so that means our job is to factor this, because solving it means to go to this trouble, yes? So solving it means you have either this or you have that, and then you can find your values when that happens. So let's solve this equation. Right, so our first job, so step 1, factor. And that means our job is to say x squared plus 7x plus 10 is equal to this times that. Because remember, this is set equal to 0. So that means if we factor it, we can make sure each one of these, either that or the other, is 0. So immediately I know it's going to be an x by x to get x squared. An x dimension by an x dimension gives x squared area. 5 and 2, I'm going to try 5 and 2. Plus 5 plus 2. Okay, here comes my scratch work. I see x squared plus 2x's plus 5x's. Is my 2 sloppy? And plus 10. That's right. 2x's and 5x's make 7x's. So yay! Okay, so check. I don't know whether you want happy face or check mark. Whatever's more pleasing, use that. Okay, so our first step was to factor. Done. And then our second is to do the either or with the zeros. So 0 factors. Okay, well, the 0 factor business said that either x plus 5 equals 0 or x plus 2 equals 0. And then from there, we write our solutions. So step 3, our solutions are -5 or -2. Okay, so we just solved this equation. We say that when x equals -2, so -2 squared is 4, and -2 by 7 is -14. 4 minus 14 is -10. -10 plus 10 makes 0. And we said the same thing will happen if you plug in -5. -5 squared is 25. 25 minus 35 is -10. -10 plus 10 is 0. Okay, so here are our solutions. And then it says graph this function. So what we are graphing, because remember, when we're graphing, we need a y equals. And then we have our quadratic. So we are going to build this parabola. And just to be sure, the vertex is at the opposite of b, which is 7, so -7, over 2 times 1, which is 2, -3.5. So -3.5 is going to be in the center of this. And I'm going to go ahead and make a table of values using this because I really want you to practice doing that. Okay, clear. X squared plus 7x's plus 10. And second table. Okay, so we just said the vertex is at -3.5. Uh-oh. Sorry. -3.5. My table's going by ones, so I'm going to go to second window, which is table set, and I'm going to count by halves. Okay. There is our peak, our vertex, and then around it you see a certain amount of symmetry. That's fabulous. Okay, so here's our center, and I'm going to go ahead and jot this down in our table of values. When x equals -3.5, put that into our equation here, and that was -2.25. When x equals -4, and how about below that even? Let's go -5 and -6, since I have my table here. When x equals -4, this was -2 as a y value. When x equals -5, y is 0. When x equals -6, we get 4. And now I'm going to go symmetrically on the other side. So instead of going below it by a half, I'm going to go above it by a half. That's -3 and -4 and why did I say 4? I meant 2. Silly. -2 is 1 above that, and -1 is 1 to the right of that even. Okay, and then symmetry shall prevail. Okay, we're ready to graph. Ooh, I am noticing something already. Here's what I see. I see that solving this and setting it equal to 0, here's where we have, for our two x's, x at -5, the y value is 0. X at -2, the y value is 0. So I see my table of values is telling us the solution to when our quadratic is equal to 0 instead of just a general y. Okay, but that gives rise to other possibilities too. So I'm going to count by ones. So 1, 2, 3, 4, 5, 6 to the left, 1, 2, 3, 4 up. -5, 0, 1, 2, 3, 4, 5 to the left. 4, -2, 1, 2 down, -3.5, -2.25. Got it. -3, -2, 1, 2, 3 down 2. Got it. Negative 2, 0. 1, 2 to the left, plot. Negative 1 to the left, or 1 to the left, and 1, 2, 3, 4 up. There's our parabola. Okay, so here's our graph, and we are seeing right here our solutions. Right there. Okay. Nice. Find where x squared minus 6, I'm sorry, x squared minus 4 hits the x-axis. Okay. Well, I mean, that means we're really solving set this equal to 0 and solve, because that is exactly what this did. We factored and solved it, and that gave us where our graph hit the x-axis. So I feel like this is just a rephrasing of this problem, except in order to do that, we just set this equal to 0. We could do that. So our job, so similar to this, the same problem would be to solve x squared minus 4 equals 0. And that means we would have to do this factoring business. So step 1, factor. X by x makes x squared. Negative 2 times positive 2 makes negative 4, and double check. X squared plus 2x's minus 2x's, no x's, and then negative 2 by positive 2 is negative 4, so yes. And then we say either x minus 2 equals 0 or x plus 2 equals 0. And we have these two solutions. Find where this hits the x-axis. The graph of this parabola hits the x-axis when x equals 2 or when x equals negative 2. All right, and just to verify that, right, we would go to y equals, clear this, we would say x squared minus 4 graph. Oh boy, I'm gonna have to zoom out, or zoom in. Zoom standard. Yes, got it. Okay, so use the graph of y equals x squared minus 7x plus 12 to factor. Okay, so now they want us to graph and use that in order to come up with the factored form. Okay. Before we do that, I need us to know when it says to factor, our solution should look something like that. Yes? Okay. Because that would be the factored form of x squared minus 7x plus 12. But it does say to graph. Okay, so y equals, clear that out, x squared minus 7x is plus 12, graph. Ooh, 1, 2, 3, and 4. Okay. So now, okay. Does that say it 2 and 3? Ick. I think it's actually easier for me to move my axis than to redraw a parabola. So I'm going to do that. There. 1, 2, 3, and 4. And it happens here and here at 3 and 4. And now we're going in reverse now. Now we have this, and we're going into our factors. So x equals 3, or x equals 4. And if I subtract 3 from both sides of this, that would say x minus 3 equals 0. If I subtract 4 from both sides of this, x minus 4 equals 0. And then, so now I'm at this stage, and then I write them as two factors being multiplied, two linear factors being multiplied. So this would look like x minus 3 and x minus 4. Double check always. X by x is x squared, minus 4x's minus 3x's, which would be take away 7x's, and then negative 3 by negative 4, positive 12. Checks out. Okay, so that was handy because it told me what my factors might be. Find where x squared plus 4 hits the x-axis. Well, up here we factored it in order to find that. We set it equal to 0 and then we factored it. What happens if we set it equal to 0 here? X squared plus 4 equals 0, and our job would be to solve this. So we said we would factor it and then set each factor to 0. Well, x squared would need to be an x by an x, and positive 4 would either be 2 by 2, 1 by 4, 4 by 1, or negative 2 by negative 2, and or other negatives. However, let's double check this guess. X by x is x squared plus 2x's plus 2x's. Uh-oh, that's 4x's. Okay, now I'm thinking, well, maybe this is harder than I thought. And in this one, I used my graph to find it. So here we go, clear it. X squared plus 4, graph. Oh, look at that. It's floating up there. Find where it hits the y-axis. Well, in this particular case, it's actually easier to make a graph of it. And say, never. It never hits the x-axis. It starts above it and goes higher. Find where y equals 2x squared plus 9x minus 5 will equal 6. Then graph both of these. Oh, tricky, tricky. Let's see. So, we need to solve 2x squared plus 9x minus 5 is equal to 6. But, there's a really big but here. Remember, if two numbers were to multiply to 6, there would be infinitely many ways to do it, and we need to be able to use this, two factors that multiply to 0, in order to pin them down. So, with that in mind, I'm thinking, why don't we subtract 6 from both sides of this thing? Solving this would be the same as solving this very similar equation, but not exactly the same equation. 2x squared plus 9x, deduct 6 from both sides. And that was just so that this would be set to 0, so that I could factor it and use that. Okay, factoring. Okay. Well, in order to get 2x squared, I'm going to need a 2x by an x. And in order to get to 11, I'm going to need 11 times 1. Oh, something's going to have to be positive and something's going to have to be negative. Let's try this first. Yeah? Okay, get my trusty pencil out because factoring never goes well on the first attempt. 2x squareds minus 2x's plus 11x's minus 11. Ah, that did it. That's the correct factoring. Okay. From there, then we would say either 2x plus 11 equals 0 or x minus 1 equals 0. So that means our solutions would be x equals 1, or, all right, if 2x is negative 11, because negative 11 plus 11 is 0, and that means I would have to scale it down by half. What's half of 11? 5.5? Or x equals negative 5.5. Okay. Use the graph of these on your calculator. Then graph both of these on your calculator. All right, so here's what's up. I am going to graph two functions right now. First, I'm going to put this one into y1, 2x squared plus 9x minus 5. And second, I am going to put 6 into y2. Okay, I'm ready. Except not super. Okay, there we go. Clear this, and I'm going to put, what is it? 2x squareds plus 9x's minus 5. And we were set to find out where that would equal 6. Now I'm going to go to my graph. Look at that. So I need you to see that it happened twice and we have two solutions. Here, when x was 1, this function, okay, did we get 1? Yeah, we did. Okay, sorry about that. And when x is 1, 2, 3, 4, 5 and a half, you see that they will meet again. So it's really the intersection. Second trace down to 5. So second trace and then 5. First curve, blue. Second curve, red. Guess 0, sure. And there is one of our solutions, or intersection. Let's do it again. So I'm going second trace, which is calculate. I'm going down to intersect, hit enter. First curve, red, blue. Second curve, red. But now I want my guess to be over here. Whoopsie. No. Aw, man. 2. Clear. Okay, it did not like that. Second calc. Intersect. I definitely hit the wrong. Yes, and yes. Okay, voila. Negative 5.5 and 6. So it actually found our two solutions. Oh, man. Oh, boy. Am I going to be able to squeeze it on here? I highly doubt that. I'm going to go to my table. And where does this peak happen? At negative 2.25. So just so that we're crystal clear here, vertex, opposite of B, over double the A, negative 2.25. And that is living at negative 15. Well, no, right below negative 15. Okay, we can do this. Let's draw in our scale. 7 and 7 make 14. And I need it to go up to 6. Okay. We are going to call this our x-axis. I moved it up. And I'm going to count by 2s. 2, 4, 6, and that makes this 2, 4, 6, 8, 10 below. 2, 4, 6, 8, 10 below, so negative 20 there. And our x values, our vertex happened at x equals negative 2.25. So, oh man, probably should have scooted this over too. Hindsight. Nope, I want to. So, instead of hindsight, I'm going to say, yep, white out. Okay, so if I want to go over to negative 6, let's put the axis right here. Okay, so that's 6, and I'm counting by ones, so this would be 1, 2, 3, 4, 5, 6 to the left. This would be 1 to the right. And 2, 4, 6, 8, 10 below. 2, 4, 6, 8, negative 20 below, or 20 below. Okay, there we go. And let's plot. So